Hi, welcome to this introduction to the task framework which exists within Nabu. Let's start with what we wanted to create. So the primary purpose of the task framework is to execute services, but do so in an asynchronous manner that is guaranteed to be executed, and it should obviously be parallelizable across servers, not just within one server, and it should be easy to use, which is the general goal for the entire Nabu platform, obviously. If you give at least the first three requirements of this to any Java person, you will get the default answer GMS, which is what we did in the beginning. We started with what we called Nabu Broker, and it was GMS inspired, but it was in the end a horribly complex code base, and it was not as easy to use as we wanted it to be. So we just looked at the requirements again. And built something from scratch, and it ended up being a really tiny framework, and it's written entirely in Nabu, so it no longer has any Java code or whatever. To start with, what is a task? By default, it's a service, so if you just create a task, by default you will be executing a service somewhere, but in a larger scope, it is a unit of work that needs to be done, and it could be anything. For example, we have a setup for running for a client, where we have a central server, and the central server will manage the tasks. So he will create tasks, he will have the start-stop functionality, all the logging, the state of the task and stuff like that. Scheduling is all done in the central server. And we have servers running in remote locations, and they just connect to the central server and check if there are any tasks for them. And then you can start divvying up the tasks to specific servers that need to do some work. In this particular case, the task itself is not a service per se, it's something that needs to be done. For example, a synchronization has to happen, data has to be pushed to the central server, something like that. A second question you might ask is, once you know what a task is, who should run it? So let's go back to the service tasks, which are the default. Who should run the service? And by default, we use $any, which means any server who sees the task can pick it up. And I've drawn a little setup here, very simple setup, which has two servers, web server 1, web server 2, and they live inside the group called web server. So this is part of our normal default naming convention, where the group simply has no number, and each instance has a incremental number. In this particular case, you could, instead of $any, you could actually type web server 1, or web server 2, or more likely, web server. So you could submit a task that can be picked up by anyone in the group of web server. Obviously, this becomes more interesting is if you have multiple clusters. For example, the web server layer could actually create a task that is picked up by the batch or a specific batch server as well, or for example by a speed layer or whatever other setup you have. So in this particular setup, all of these are valid combinations, targets, and there's one that I haven't talked about yet. It's the $all. You can actually submit a task that is run by all servers. Then we can wonder, when should it run? And by default, it's now. So if you create a task, it should be run immediately. This is the default. But when you create a task and you have a single task, you can actually choose to run immediately, but also run in a particular time frame. So for example, this is the syntax for periods. So within 1 day. You can also say run at and specify a date. Or you can just use a cron-like scheduling, and this particular one means seconds, minutes, and hours. So it should run the next morning at 2 a.m. You can also set a schedule for an entire queue. So either you set it on the task, or you can say any task submitted to this queue should follow a particular schedule. And then again, you use the cron syntax to indicate what it is. You can also use schedulers separately, and they will actually create tasks across different queues if necessary. Then how many tasks can run at the same time? So we're talking about concurrency. The default is 0, which means you have a serial queue, and that means there's only one task on that queue running across the cluster, and the order is guaranteed at that point. Once you set concurrency to something that is not 0, it is actually interpreted as the amount of tasks that can be run simultaneously across the cluster. In this particular case, the order is not guaranteed. Talking about order, in what order should the tasks be run? by default, it is creation order. So the moment they're created, they get a unique incremental ID. Based on that ID, they will be executed. But if you schedule them in the future, they actually do not take part of the queue until the scheduled time is reached. So even on a serial queue, scheduled tasks in the future are ignored until that future becomes now, and then it will become part of the queue. You can also stage a task, and that means a task will wait for some external trigger to become active. And for example, the workflow system uses this to create tasks that only activate once a particular workflow reaches a particular state. There are some cases that no tasks are executed, on a queue at least, and that is if a queue is in error and it's a serial queue, no further tasks are executed until it is resolved. Resolving an error could be setting it to failed, which is a permanent state. Another reason could be that the queue is paused, and it could be paused because someone manually put a pause on it, but it could also be that a queue is waiting for another queue to finish. And this is interesting if you're doing batch calculations. So you could have a queue of tasks, and once they finish, they could activate in another queue and run the task there, which is interesting if you have batch processes that need to run in a certain order. Just a few more fun facts before we dig into an actual demo. You do not need a dedicated server, so it just runs on your servers. It only has a persistent options, so you cannot use the task framework and not persist it. But if you do want non-persistent asynchronous execution, which is no longer guaranteed, obviously at that point, you can do so very easily, just not with the task framework. It can also work with arbitrarily large data streams, but you do need to turn on data store support for that. You can also work with dynamic queues, but you can either work with queues that you create intentionally, named queues, or you can work with dynamic queues, and they are created for a root service, and they are when the root service is done, it will actually be put into a different state, because no one can from that point on publish to the queue anymore. It's a temporary queue, and it is interesting for batch processes again. There is obviously support for stuff like transient error detection, automatic retries with exponential backup, and of course you can also do manual retries. You can either submit tasks atomically or as part of a larger transaction. And on this particular laptop I'm doing the presentation on, you can easily reach 1,000 messages a second with just one publisher thread, so performance shouldn't be too much of an issue either. Okay, so that's it for the introduction. Let's look at a demo. Let's start by creating a service, a block service, my service for example. This assumes you've already seen the tutorial about block services. Let's add a map statement, and in it let's simply do a server log, which basically writes to the server log. Let's just print out test. If we actually run this, and you switch to the server log, you will see the log appear here. Now what we want to do is we want to do this asynchronously, so this is being done synchronously as we run the service. What we can do now is we can select the invoke, and then we have a target. By default the target is not filled in, which means it's the main thread, but you can also choose to run the task somewhere else, so the service. For example, we could run on the task framework. There are other ways like shared executors, and you can do custom ways of running the service, but the task one is provided. And simply by selecting it, it will now run through the task framework, so we can actually start it. And we still see the log appear here. But if we now check with the queues, we see that a new queue has been created because we did not choose a particular queue, which means it will create a new queue, which is set to published when the root service is done. And as you can see here, we have the task appear. We can then rerun it, and you will see the output appear again here. And you can obviously look at some metadata. We have the logs here. You can see that it was picked up twice and processed twice. Obviously we have a queue here. We may want to put it there, so we can select the once we have a target here, we can select the queue by typing it here. So we simply say publish it to the queue test. If the queue test does not exist at that point yet, it will be created as a named queue. So again, we can run it. We see it appear here. And if we look at this queue, it now has a single task, which again, obviously, we can reprocess. It appears here. There's a lot of other options that you can set. For example, you can add some metadata, which is saved as key value pairs in database for additional searchability. You can choose the run at that we spoke about to run in. You can do additional metadata for easier matching. You can choose whether to enable data store or not. Here you can set the task target, which could be, given the example in the presentation, could be, for example, batch. We can control the transactionability of the submits by using this. We can set the schedule according to the cron syntax. So if we, for instance, fill in the schedule that we use in the example and we run it again, this time we will not see the log appear here. But if we switch to the interface, you can see that we have a task which is set to created and is scheduled for tomorrow at 2 AM. If we now take off the schedule and I run it again, you do see it appear here. So as I said before, this is a serial queue, but this task is not actually part of the queue until this time arrives. So we can still do serial processing here. So I quickly want to show you what happens in case of an error. So let's create another service, my other service. We can still do a server log. This is another service. Obviously, if you run it, we just get this particular output. And let's run that service here. So let's add this as a task on the queue test. And let's add an exception to this service. So if this runs, it just calls an exception. Let's add a code, my code, and something went wrong as a message. If you now run this, you can see that exception appears here, but you can obviously see it better in the GUI. If you have an error here, you can then check what the error is about, and you see here my code, something went wrong. You could then fix your error, so to speak, and rerun the task, and now it succeeds. Okay, so that's it for an initial introduction into the task framework. I hope it was interesting. There's again a lot to be told, but that will be for a next video. Thanks.